Okay, guys, let's do another little bit more review for Unit 4, IM3. Let's go. So, guys, no one's asked me these problems before. The way you evaluate logs, and especially when they tell you to use a calculator, guys, and notice how this one has even a decimal in it, is you're going to use the change of base rule. And it's really simple to learn. You ready? I'm going to change this into, using change of base into, I'm just going to use change of base. You ready? This, you see, becomes the log of 2.4 divided by the log of 6. That's it. That's how you do change in base. Now you're going to take your calculator. Watch carefully here. If you look at the bottom of the screen right here, let me slide this up a little bit. I'm going to put in the log of 2.4. Now, guys, depending on your calculator, you're going to close it up with a parentheses. That way, when you do divide, it doesn't confuse the divide as part of the log there. And then you're going to do divide log of 6, close parentheses again. The answer is 0.4886. 0.4886. Okay? Now, make sure you use enough significant digits that your teacher likes. Usually they're going to want at least 4 to 5 decimal places. Let me make that a little bit neater, 0.4886. But that's how you evaluate using a calculator. And to make a long story short, guys, the log button on your calculator is base 10. This is a base 6 log. So that's why change of base is so critical, because a typical calculator only has base 10 and a natural log button. Okay? So let's do it one more time. How would I do log of 5 base 2? Notice that is a base 2. Well, I'm simply going to do log of 5 divided by the log of 2. It's that simple, guys. Okay? So, if you look down the bottom of the screen, I already have it done. Clean up my little mess there. So, as you can see, I did the log of 5, divide log of 2. Again, make sure you use those parentheses to close off each log function that you type in. And there's the correct answer, 2.3219. If that was higher than a 4, like a 5 or higher, I'd round that up to 0.322, right? But again, discuss that quickly with your teacher, how many significant digits he or she wants. All right? But that's how you do logs in the calculator. You use change of base, and you type it in your calculator. Now, guys, this is a problem where we're going to condense it. Okay? It's going to say condense. Well, how do we do this? Well, the first thing I'm going to do, guys, is I notice this 3 is timesing this log, correct? This 6 is timesing this log, correct? And in the rules of log functions, multiply becomes a power. I'm going to bring it up here. I'm going to bring this up here. And I'm going to have the log of x base 2 of actually x cubed. The minus is still there. We're going to take care of that next. And over here, I have the log base 2 of y to the 6. Because when I bring that 6 up, it becomes a power. So when we're condensing, guys, multiply becomes a power or exponent. You have to know that. It's one of the 3 main rules with logs. Now what? The next rule we're going to discuss is minus. With logs, guys, whenever you minus, it's a division problem. So what I'm going to end up with is a log base 2 of the x cubed. So I'm doing this, and that minus right there means I'm going to divide now the y to the 6. So this is what we call condensing again. So as I was saying, we call this condensing. And the reason why, see how this was all spread out initially, right? And now it's one nice, concise answer. Okay, guys, we got one more, I believe. Now, notice how this one is already condensed. It's just one compact log function. That's why what we're going to do is called expand. We're going to use the same rules that we just used on the last problem, but backwards. And we're going to expand it out. So check this out. First thing is, it may look confusing, but we have 11 to the 6th power here, timesing this cube root of 3. So the first thing we're going to handle is that multiply, therefore. So I know multiply, just like with exponents, you end up adding, right? So I know I'm going to get the log base 9 of 11 to the 6th power plus log base 9 of the cube root of 3. That times, in other words, became a plus. Okay? Now what? Well, we have a 6th power here, don't we? A 6th power, if you bring it down, becomes a multiply. So I know I now have 6 times the log base 9 of 11. Plus, now what about this over here? Well, you have to understand that a cube root is really a 1/3 power, just like a square root is a 1/2 power. So this 1/3 power, I'm going to scribble it out here, guys, because I have it out here now. I know that 1/3 can come in front, so I have 1/3 log base 9 of 3. Okay? Now this one actually has an evil trick I just noticed in it. So bear with me here. Do you guys agree that 9 is a power of 3? Right? So I'm going to be able to simplify this log. Alright? So listen carefully. This is a separate problem in itself. I'm going to circle it in red here. I know that if I'm given the log base 9 of 3, as I was saying before the phone call there, guys, we have the log base 9 of 3, right? Well, think of it as one of those other problems. We want to evaluate what value x is at. Well, we know that 9 to the x has to be 3. And the trick I showed you in one of my videos was 9, do you agree, is really a 3 squared? So see what I did there? So if 3 squared to the x equals 3 to the 1, notice how I have now the same base of 3. Logically, that means 2x has to equal 1. And therefore, x must be 1/2. So that becomes 1/2. So my final answer is 6 log base 9 of 11. See, 11 and 9 are not powers of each other. So that's why you can't really simplify that. Plus 1/3 times 1/2 is 1/6. And that should be the answer that your teacher will accept. Okay, guys, hopefully these videos are helping out. Send me pictures of some other problems if you want more practice on them with me. All right, I'll see you around.